Okay, so I will show you how to solve all problems in practice quiz. Um, but firstly, I would like to remind you two things, right? About motivations of integrals. Why do we need to study integrals? Because first we need to solve the area problem, right? Area problem. So when you need to find area of the region enclosed by a curve of some function on some interval and x-axis, you need definite integrals, and that's how we define definite integrals, right? Use Riemann sum, something like that, okay? And the second motivation is how to recover a function if we know its derivative, right? The first problem in here is that you need to find a general solution. Find a general solution of the following differential equation and check the result by differentiation. So you have dy dt is 48 t to the 5. You need to find y, right? And then they ask you to check your solution by differentiation. So for this, we know the derivative. We need to recover the function, right? Just recover that. So we apply integration, right? To both sides, we get the integral du dy dt equal to integral 48t to the fifth and then dt. So since this is a number, we can print it out. T to the 5 and then dt. And here we use the power rule, right? The power looks like, okay, for p not negative 1, you have x to p dx equal to, remember, that is x to p plus 1 over p plus 1 plus c, right? P plus 1 plus c, okay? So if we apply the power rule for this integral, we get it is 48 t to the 6 over 6, right? Plus constant. That is in the right hand side. In the left hand side, you have integral d. I think I have to erase dt in here, right? So it's just dy, because we already bring dt into the north side. We use cross multiplication. You see? So basically, we have here dy equal to 48t to the 5 dt. So only after that we can integrate both sides. So in the left hand side we have just y. So our function is y equal to 48 t to 6 over 6 plus c. And if you simplify 48 6, you get a t to 6 plus c. Okay, in this problem, they ask you only to find general solution, right? And they don't ask you to determine c. In case if we determine c, we need an initial condition. Do you remember that? We need an initial condition. All right, and then the second part of this question is to check the result by differentiation. So what does it mean? Check the result by differentiation. Means if you have y equal to a t to 6 plus c, right? So you differentiate both sides, right? As a t to 6 plus c derivative. If you differentiate y prime, you get exactly 48 t to the 5th, so you are good. Make sense? Of course, you know, c derivative is 0 because c is constant, and this is 48 t to the 5th. That is the first question, so I think you can solve this in 2 minutes. I mean, if we know how to differentiate and if we remember the power rule. Any question for me? No? Okay. Power rule is easy enough. The second question is also about power rule. Evaluate indefinite integral. Right? That is another form, you know, when we have radical function, we can convert a radical function into power, right? So if you have functions like this, you can convert into the form x to 8 over 7 dx, right? And you use the power rule, and in this case, p is equal to, what is p? 807, yes. 807, right? So you apply the power rule for that p, you get this is equal to x 8 over 7 plus 1, right? Over 8 over 7 plus 1 plus c. Don't forget this number and this number should be the same, right? Don't forget about it. So you just close your eye. Once you get this number, you just copy it. Copy it to this place. This is it. Make sense? Yeah, you can leave your answer like this, or in case you can simplify that. For example, 7 with 1 and 8, you get 15 over 7, and when you divide by 15, you flip that, and you get 7 over 15, x to 15 over 7 plus c. Again, right? If you remember the power rule and you use that fluently, you can solve this in 2 minutes. Is that right? Next question. Evaluate the, yes.
The answer was 15 over 7.
The answer is 7
Okay.
over 15, because we flipped it. I mean, 15 over 7 is this.
Okay.
Next question, evaluate the definite integral from 4 to 7, 4 over x squared minus 1 dx. Again, in this case, we need the power rule, right? In the previous example, you see radical function, and when we convert the radical function into power function. In this case, we have fraction, right? And we might convert fraction into power. Is that correct? So your fraction looks like 4 over x squared. What's that? What is 4 over x squared? How to convert this into power? Yeah, that is 4x to negative 2, right? So the power in this case is negative 2. 4 to 7 minus 1 dx. So yesterday I showed you 2 ways to solve this integral. First way is that we can split this integral into 2 integrals, right? For 4x to negative 2 and for negative 1. Or you can find antiderivative of the whole function and then plug numbers into that. Do you remember? So we will do this in second way. So I will find antiderivative of the whole function and then plug 4 and 7 into that, right? So antiderivative of 4x to negative 2. 4 is just 4, right? I don't care about that. It's just coefficient. Now I apply the power rule for x to negative 2, where p is equal to negative 2, right? So I have the following one. I have x to negative 2 plus 1 over negative 2 plus 1, right? I just copy that. And then for negative 1, negative is negative, and antiderivative of 1 is x, right? Antiderivative of 1 is x. I don't need c in this case, because we are evaluating definite integral, right? When we evaluate definite integrals, we don't need c because, if we use the first fundamental theorem, so c will disappear. And then I evaluate this function from 4 to 7. So you need to plug 7 and 4 into this and find the answer. Let me simplify this first. Okay, I have 4 times x to negative 1, right? Here is x to negative 1. I flip it right 1 over x. So here is negative 2 and plus 1 is negative 4. Basically, I have negative 4 over x, right? And then minus x. Then from 4 to 7. Now I plug 7 into that. I get negative 4 over 7 minus 7 minus negative 4 over 4 minus 4. So that is, simplify that, you get the final answer. So again, if you know the power rule, you can solve this problem in maybe 2 or 3 minutes. Any question for me? No? All right, so let's move to the last question. Again, power rule. Again, power rule. So I write this. Last question to ask you, the answers to evaluate this integral 1/3 minus t 2/3 dt. And so you have, two polynomials in here. Power 1/3 and 2/3. So apply the power rule for that. I will find antiderivative of each function and then compile all together. So for this function, I get t 1/3 plus 1 over 1/3 plus 1, right? Because in this case, p is equal to 1/3. Is it right? So the second function minus. Here I have t 2/3 plus 1 over 2/3 plus 1. And then I evaluate this from 91 to 0. So at 0, the function is 0, right? Because when you plug 0 into this, you get 0, 0, 0, 0 in here. We only need to evaluate at -1. So I write here 0 minus. Okay, -1. And here the power is 4/3. Okay, and here I can write 4/3 minus t. In this case, I have -1 to 5/3, and then 5/3. Okay, so what is this? 91 or 1? This is 91 or 1. One or 91. That is 1, right? Why? Because if you convert this into, into the radical form, right? You can see this is equal to 91 to the 4 and then cubic, right? -1 to the 4 is 1. It's 1, right? 1 applied cubic, you get 1. So this term is 1. But how about this term? Is it 1 or 91? Here we have 5 over 3. All numbers are odd, right? So this is 91. Okay? So you have 1 over this, minus 91 means plus, right? So the answer is negative 3 over 4 plus 3 over 5. And that is -1. 15 and then 12, you have 27 over 20. 27 over 20. Done. Okay, so that is practice test.